Alright, let's look at an astronaut on Earth that weighs 1,000 newtons. That's 1,000 newtons right there. And let's take him to a planet, Planet Green over here, that has twice the mass of Earth and has twice the radius. So he's twice as far away. That gives us 2 times the distance that he was away from the center of the Earth. And this was d, this would be 2d. And the planet itself is twice the mass, but his mass stays the same. Alright, so the relationship we have that ties all this together, force proportional to m1 m2 over d squared. Now the mass getting larger, that should make his weight go up, but the distance is getting larger too, that should make his weight go down. Let's see who wins. So we're most concerned with how things change. I don't care what the actual mass is, I care that it's actually doubled. So I'm going to put in 2 m1, and now the mass 2 doesn't change, I'll just kind of leave it there. And the distance has also doubled. Don't forget to square all of that down in the bottom. Alright, so let's scoot this whole guy up here so we can look at it. There we go. So we have 2 m1 m2 over 2d squared. Now I'm going to square the 2. That gives me a 4. I'm also going to square the d, the distance. Alright, so I have 2 over 4. Now all of this, that's what I started with. That was my old force. That's what it used to weigh. m1, m2 over d squared. But I have this 2 over 4 out front, which means 2 over 4, I can reduce that to 1/2. Now since m1, m2 over d squared, that's my old force. That's what it used to weigh. So the new force is going to be 1/2 of what that old force was. Alright, so let's look at that new force. He used to weigh, let's double check again. He used to weigh 1,000 newtons. So 1/2 of 1,000 newtons is 500 newtons. Now you could also look at this a different way. We used the formula we had, and we kind of used algebra to solve it. You can also reason your way through it. You know that the force, oops, get back my pencil, the force and mass are directly proportional. And you can explain that. This may take longer to write out, but if it makes more sense, it's a good way to do it. You know that they're directly proportional. So if you have 2 times the mass, you're going to end up having 2 times the force. So twice 2 times 1,000 newtons, was what we started with, would give us 2,000 newtons. Alright, so that's part of it. The other part is taking care of the distance. Myself a little room here. I'll move this over. So you know the distance also doubled. Well, distance and the gravitational force here, those are not directly proportional, and they're not inversely proportional. It's an inverse square relationship. Alright, so force is proportional to the inverse square of the distance. Okay, so now you know the distance doubled. Square it and invert it. So if that's 1 over 2 squared is 4. 1 over 4 is 1/4. Now that would be 1/4 of the 2,000 you just found, because both of these things are happening. So 2,000 divided by 4, or times 1/4, gives us 500 newtons, which should be, and it is, the same thing we got before from the explaining it algebraically. I tend to think the algebra one is a little more straightforward. You're kind of doing the same thing, just explaining it in fewer steps. This equation really summarizes both of those relationships, directly proportional to the mass, inversely proportional to the square of the distance, and you can plug in both steps right at once and get right to an answer right away. If it makes more sense to you to instead talk your way through it, explain your way through it, say that, okay, force and mass are directly proportional. If one doubles, the other has to double. Show that work. And then say, okay, I know that the gravitational force and distance are inversely proportional to the square of the distance. Okay, square what happened to the distance, take the inverse of it, and then show how to change that original force. You can explain that as well. But whatever you do, in the end, the most important thing is to communicate how you got to an answer, communicate your reasoning, and that's what we're trying to go for.